Okay, so we're going to need to remember our slope. Need to remember how to put it into slope-intercept form, write an equation of that line in slope-intercept form, what the slope is perpendicular to another line, and then you're also going to have to solve a system of equations, okay, to find your other point. So my first example here, I have line A contains points 1, 2, and 5, 4. We want to construct a line perpendicular to line A through point P, which is at 1, 7. Then find the distance from P to A. Okay, so that whole problem, I laid out all the steps for you. Okay, this is how many steps this problem takes. So first, I want to graph the point and line A. So I'm going to graph line A. So I have a point at 1, 2, and a point at 5, 4. Okay, and I forgot to hand out your rulers. I'm sorry. If you want, you can plot point P as well. Right away. So it looks a little bit nicer when you connect
And find the
the
distance
point.
from P to
Oh my gosh.
A. 6, 0 from the source.
Oh my God. You gotta change that. Ashley, thank you. Perfect. So 3 left. And I can just use a protractor. All right, so now I'm going to connect these 2 points. Okay, so that line that I formed is line A, so I'm going to label it line A. Now, if you didn't plot point P, you should plot point P. That's at 1, 7. Okay, and I'll label that point P. So now what I want to do is find the equation of line A. So I need the slope and the y-intercept of line A. So our slope, since I already graphed it, I can just count. Okay, slope is rise over run. So I go up 2 and right 1, 2, 3, 4. And I can reduce that to 1/2. Okay, so my slope for line A is 1/2. So as of right now, my equation would be y equals 1/2 x plus b. Now I need to find what b is. Okay, so I need to just choose a point on that line. So either of these 2 points you could choose. So I'm going to choose that first one, 1, 2. And I'm going to plug in 1 for x and 2 for y in order to solve for b. Okay, so I have 2 is equal to 1/2 times 1 plus b. Now to get b by itself, you're going to subtract 1/2 from both sides, right? So I would end up with 2 minus 1/2 is equal to b. Okay, so here, in order to combine your fractions, you need a common denominator. Okay, so right now I have 2, and 2 would normally be over 1. So I need that denominator to be 2. So I can change that to 4/2 minus 1/2 equals b. Okay, so then I'll end up with 3/2 is equal to b. So now I have my m and my b value. So now I can write out my equation of that line. So I have y equals 1/2 x plus 3/2. Okay, so that's my first part. I had to find the equation of line A. Next, I need to find the equation of the line perpendicular to line A and through point P. Okay, so that's what number 3 is. So if it's perpendicular, what do I have to do to my slope of line A? The reciprocal and the opposite. Okay, so to find your perpendicular slope, you need to take the opposite reciprocal. So my slope here is 1/2, it's positive. For it to be perpendicular now, it has to be negative. That's the opposite. And then reciprocal, you need to switch your fraction. So now it's 2. So my slope of the line perpendicular will be -2. Somebody say why? Okay, now I have to pass through point P. So right now I have the equation y equals -2x plus b. And again, I need to find that y-intercept of b. So I'm going to plug in my point P, which is 1, 7. Now for this one, you can't just choose any point. You need to use point P. And again, I'm going to plug in my x and y values. So I have 7 is equal to -2 times 1 plus b. You're going to add 2 to both sides.
B equals 9.
So b will equal 9. Okay, so now I have m and I have b. So I can write out that equation. So I have y equals -2x plus 9. Okay, so again, what we're trying to do is find the distance between point P and line A. Okay, the shortest distance between point P and line A is perpendicular. Okay, that's why we're finding the equation of the line perpendicular. So we want to find where this line P, that's perpendicular to A, intersects line A. Okay, so we need to find that point. Now to do that, we're going to solve the system of equations. Okay, so we need to list both of our equations that we just found. So the equation of line A and the equation perpendicular through point P. All right, so to solve this system, since both of these are equal to y, I can just substitute, okay? So we're going to use substitution. So I'm going to substitute -2x plus 9 in for this y, since it is also equal to y. So we'll have 1/2 x plus 3/2 is equal to -2x plus 9. Okay, both are equal to y, so they equal each other. Now I just can solve for x. Okay, so I'm going to add 2x to both sides. Again, I need a common denominator for my 2x and my 1/2. So I have 1/2 x plus 4/2 x. And then I still have this 3/2 equals 9. Okay, so again, I changed this 2x to 4/2 so that I can combine these two. So now I have 5/2 x plus 3 halves equal to 9. What should I do next? Subtract 3 halves. Okay? So I'm going to do that up here. So I'll have 5 halves x is equal to 9 minus 3 halves. So again, I need a common denominator here with my 9. So I have 5 halves x is equal to 18 halves minus 3 halves. I got a common denominator. So 9 is like 9 over 1. To change that denominator to a 2, I multiplied by 2. Whatever I do to the bottom, I have to do to the top. So I multiplied 9 by 2 to get 18. Does that make sense? What do you mean, no? I just multiplied by 2. Top and bottom by 2 to get my new fraction. So now I can combine those two fractions. So I have 15 halves. Now to get x by itself, I'm just going to multiply by that reciprocal to both sides. Okay, that way each of those cancel out. Over on the right, I can cancel out these 2's right away. Then I have 15 over 5. What is 15 over 5? Okay, so my x value is 3. Now when you're solving a system of equations, you also need to find your y value. Okay, so we're finding a coordinate point. So with that x, we just need to plug it into either of these two equations and solve for y. So I'm just going to use this one because it doesn't have any fractions. So to get y, we'll have negative 2, plug in 3 for x, add 9. So I have y equals negative 6 plus 9, and y will equal 3. So my coordinate point where these two lines intersect is at 3, 3. Okay, so up in your picture, I know I have point P here. If I were to use my slope of my line perpendicular, I would go down 2 and right 1 and make that point. And I could connect those. Okay, and you'll see that those two lines do intersect at 3, 3. And that's what we were looking for, was that intersection point. On your assignment, it won't be that nice. It'll be a fraction, so you can't use your graph.
Wow. Thanks, Brad.
You're welcome. You can't just assume that it's at that point. All right, so again, in this entire problem here, we're trying to find the distance between point P and line A. That's why I wanted to find where they intersect. So now what I need to do is use the distance formula. Okay, so we're going to use point P, which again is at 1, 7. And our intersection point that we just found, they called it Q. That is at 3, 3. And we're going to use this distance formula. So again, if we need to label our points, we're going to do that. So we have x sub 1 and y sub 1, x sub 2 and y sub 2. And then I can just plug those in to find that distance. Okay, so we have the square root. X sub 2 is 3, minus x sub 1 is 1. That's squared. Plus y sub 2 is 3, minus y sub 1 is 7. And that's squared. Okay, from here I just need to simplify. So I have 3 minus 1, 2 squared, plus 3 minus 7, It's negative 4 squared. I'm going to square both of those terms. So 2 squared is 4. It is. Negative 4 squared is 16. So I get the square root of 20. Do you remember how I can simplify that radical?
Yes.
What can I simplify the radical to?
2 squared. 2, 5.
2 square roots of 5. Okay, and this will be in units because we're working on the coordinate grid.
I'm not. So again, this how?
What?
I'm not. Right.
You know what? Me neither, but we're here, so that's what's happening.
Why can't we watch a movie?
So if you look at 20, you multiply 4 times 5 to get 20, right? So I took the square root of 4, and that's 2. So that comes out, and then 5 stays in because you can't take the square root of 5.
Why do you just complicate it?
It's not. So what we're doing again here, this is honestly all one problem. It's not 5 different problems. Okay? It's one problem. You had to find the distance between point P and line A, the shortest distance. To do that, you needed to find the line perpendicular, okay, to line A, and then find where they intersect so that you can take those 2 points and find the distance between them. Does that make sense? All right, so on the back, this one is similar but different, okay? So this time, you're given 2 parallel lines. You're given 2 parallel lines, and we're still finding the shortest distance between those 2. Okay? So, again, first step, we want to graph both of our lines. Okay, this time we're given these 2 equations. Okay, y equals 2x plus 1, and y equals 2x minus 3. So for the first one, line L, we're going to plot our y-intercept at 1. Okay, then I'm going to use my slope to plot a second point. So we're going to go up to right 1. Okay, then I can take my straight edge and connect the 2. Okay, so this first line, this is line L. Second line is line M. Again, using the y-intercept is -3. And then the slope is 2. You're going to go up to right 1 from that point. And again, connect those 2 points. Okay, and they should look parallel. This line is line M. Now we want to sketch a line P that's perpendicular to both of these. Okay? So you need to use the y-intercept from one of those lines. Doesn't matter which one you choose. Just you need to choose it from one of them. So I'm going to choose this first one here. Okay, so my y-intercept is 0, 1. Okay, and that's from line L. You don't have to make your L like that. It's okay. So using this y-intercept, I'm going to make a line perpendicular to line L through this point. Okay? So if I'm looking for a line perpendicular, my slope has to be the opposite reciprocal of the one I already had. So instead of 2, it should be -1/2. Okay? So then I can write out the equation of my line since I want it to go through this y-intercept. So that has to be its y-intercept as well. So my equation would be y equals -1/2 x plus 1. Okay? And I can draw in that line. So again, my y-intercept is still at 0, 1. So I'm using this point. And then I'm going to use my slope of -1/2. So I'll go down 1 and right 2. At that point, and we can connect them. Sit down.
I'm going.
Okay, so the line I just drew in is line P. And it should be perpendicular to both line L and line M. So what we want to do here is find the distance, the shortest distance between L and M. Okay, that means I need that perpendicular distance. So we have one intersection point that we can use to find our distance. We need to find this other one. Okay? Again, to do that, you need to solve a system of equations. Okay? This one isn't nice like the last one. Okay, it's a fraction. So we need to use line M and line P since that's the intersection we're trying to find. That's why it says the equation not used in number 2. That's why I had you write out from which line. So we need to use line M's equation. Okay, so that is y equals 2x minus 3. And we also need to use our equation of the line perpendicular. So y equals -1/2 x plus 1. Okay? So again, just like on the front, since they're both equal to y, we can set them equal to each other and solve. Okay, so we have 2x minus 3 is equal to -1/2 x plus 1. I'm going to add 1/2 x to both sides. Okay, again, I'm going to change this 2x into a fraction with a common denominator. So we have 4/2 x plus 1/2 x. And I still have that minus 3 equals 1 on this side. So since I have this common denominator, I can add those numerators. So I have 5/2 x minus 3 equals 1. I can add 3 to both sides. So we have 5/2 x equals 4. What do I do to get x by itself? Multiply by the reciprocal. Okay, so I'll end up with x is equal to 8/5. From here, I still need to find y. So I need to plug this into either of my equations. I'm just going to use the top one. So we have y is equal to 2 times 8/5 minus 3. Okay, so I'm going to multiply here. I have 2 times 8. That's 16/5. Can I change this to a common denominator right away? Are you good with that? So if this is 3/1, I need a common denominator of 5. So I need to multiply 3 by 5 and 1 by 5. That's 15/5. So y is going to equal 1/5. So my coordinate point will be at 8/5, 1/5. Okay, and that's your point Q. So now I'm able to find that shortest distance between my parallel lines. I'm going to use my y-intercept. Okay, so your y-intercept from number 2 was 0, 1. And the intersection point with your perpendicular line and line M, we just found, is 8/5, 1/5. Now for my distance formula, again I can label my points. We have x sub 1, y sub 1, x sub 2, y sub 2. Okay, and we just have to plug those in. Okay, so x sub 2 is 8/5 minus x sub 1 is 0 squared plus y sub 2 is 1/5 minus y sub 1 is 1. Instead of writing 1, can I write 5/5? Okay, so now I have 8/5 squared plus negative 4/5 squared. So when I have to square a fraction, you need to square the numerator and the denominator. So I have to square 8, that's 64, and I have to square 5, that's 25. Same thing here, square your numerator. I have negative 4 squared is 16, and 5 squared is 25. Now I can add 64 and 16. That's 80. Okay, I'm okay if you write this one as a decimal. I didn't. I actually simplified the radical, but I don't know what the decimal is, so you're going to have to figure it out. So this is about 1.8 units. Okay, and that would be the shortest distance between line L and line M. Okay, that's why you're finding that perpendicular, okay, because your perpendicular is your shortest distance. So with this last question here, I want you to explain in your own words how you would find the shortest distance between parallel lines. Now keep in mind that is what we just did in this problem. Okay, so your own words, use complete sentences, talk to each other if you have to, and write out the answer to that problem. All right, I want you guys to talk to each other about what you wrote or what you think or how you would find that shortest distance between parallel lines.
That sounds right.
All right, so this is what I had written out. Okay, so to find the shortest distance between parallel lines, you would have to find the equation of a line perpendicular to both of those parallel lines. Okay, then you want to find the intersection points of the line perpendicular to both parallel lines, and then use those points in your distance formula to find that distance. Okay, so it has to be a perpendicular line. Okay, it's not just a line that intersects both parallel lines. It has to be perpendicular to be the shortest distance. Okay, does that make sense? Yeah? Okay. So